Good evening. My name is Derek Solberger. I am an instructor of data science, and this is going to be my first ever video recording of a lesson in how to do some data analysis. What I hope to do is to take an example from the Tidy Tuesday that you see in front of you, where we get weekly data sets that are available for practice. And from there, what I hope to do is kind of give us a sense of what it's like to go from the data through the exploratory data analysis, some calculations, and finally produce some sort of result from this. Alright, looking at the data set this week, it's provided by Our World of Data, and it's about global plastic waste. This is a topic that is of particular interest to a lot of students of mine, so I'm glad that I get a chance to look at this as well. I should have mentioned that I want to do these explorations from scratch. Therefore, I have barely looked at the data so far. I might have seen a couple of tweets here and there what other people have done. I, at the moment, do not know how easy or difficult this data is to work with, and we'll just see how far we get. I'm aiming to make this video about 30 minutes long. In particular, the author noted that the variable names are unclean in some sense, and that might be something that we look at in a bit. So what I'm going to do is, there are more clever ways to download the data, but I'm kind of old-fashioned. I'm going to save these spreadsheets onto my computer. Give me a minute here. And always keep a copy of the documentation, because you're doing this for a very professional setting. Now, for organization, I am going to keep all my, sorry, let me see if I could not have so much on the screen. I'm going to keep all my files in one place so I don't have to worry about the file management as I go along. Knowing that Tidy Tuesday has a new data set every week, I'm just going to label this with this particular Tuesday's date and put the 4 files there. Admittedly, since these are CSV files, I am going to take a few moments, look around, see what kind of data we got. This CSV file, yeah, looks quite complicated compared to what we usually have in a classroom setting. So this is actually or did I click the wrong thing? Sorry, I haven't done this in a while. So what I'm hoping to do is to take comma separated values like this and put them into a relatively easy CSV file without having to do a direct download through the R code, but that is possible as well. There is a way to copy and paste this into Excel and then convert this into a nice spreadsheet, but that's kind of roundabout. Let's just go with the recommended method they have here. Alright, the tool of choice is RStudio. What I'm going to do is make a Markdown document. Just call it today's date for now. Again, I don't really know what the data looks like at the moment. And we'll copy and paste the code to load the data here. Now at the top, I like to have a separate code block for the packages that I might use throughout the Markdown document. Hold up here, sorry. This is an R Markdown document. I'm going to make sure to save this in that directory that I made earlier. The tidyverse is a very convenient way to load a lot of packages all at once that a lot of us intermediate data and now analysts use to look at our data. There are some so-called conflicts between various packages over the years, and thus what I'd like to do is to set the warnings and messages to false so that this part doesn't come up right now. And then let's go ahead and load our data frames. Some sizable data frames here. About 20,000 rows or observations each, 6 variables each. Again, some warnings pop up. Gotta worry about the data types, whether or not they're characters or doubles. But I don't want this to appear every single time, so once again I'm gonna throw that into a code block with message equals false and warning equals false. Next, I'm going to view the data. For the most part, I actually do that here in the console. I have our 3 data frames that we can see up in the right here in the environment. We have coast versus waste, mismanaged versus GDP, and waste versus GDP. Simply using the head command to see the first few rows. Let's look at our first data frame here. We have column names called entity, code, mismanaged plastic, coastal pollution, total population. Those are our 1, 2, 3, 4, 5, 6. Notice that we're going to have to contend with some missing data for some countries. In particular, some countries apparently did not keep track of their waste totals in the past, a couple of centuries ago, and that makes sense. We could also simply go up here, click on the data frame, and maybe get a cleaner view that I was hoping for earlier with Excel spreadsheet. Fortunately, the units are fairly obvious. The persons who arranged the data noted that the plastic waste is measured in tons. Population, of course, is in number of people. And we got some data to consider here. Trying to see if there's a... . It seems like the whole entire fourth and fifth column are empty to you. Well, let's look at that. We have our cost versus waste. We have our mismanaged waste column. And notice when your column name has multiple words, the convention in R is to put them inside these backwards apostrophes. I want to find out how many missing values there are. I think probably be the best way to do this. I want to count how many values inside that column is missing. Oops, got a parenthesis. And we got about 19,000 out of about 20,000. So there are about 1,000 entries such as here with the Channel Islands, where we do have some data to work with. And imagine that's similar to the coastal population. Oops, forgot to press this again. About the same deal, about 19,900 missing values out of about 20,000. So not that many to work with. At least for the mismanaged plastic waste column and the coastal population column. By the way, Gapminder is a very popular data set in the data science community. It's useful for population numbers and demographics. Alright, now looking at our second data frame that we're supplied with, mismanaged versus GDP. Once again, we seem to have a couple of columns here that have a lot of missing values for the lack of historical data. Let me see if I could track down how many missing values there are. This time it's in this data frame, mismanaged versus GDP. It's in the per capita mismanaged data frame column. And about 22,000, well, there are 22,018 missing values out of 22,204. So that brings up the question is, in this analysis, what I'm thinking is in this analysis, is that going to be enough? We're going to have about 150 to 200 observations of data. Is that going to be enough to make an interesting analysis, and if need be, a statistical analysis? Something to consider there. And let's go ahead and look at the third data frame. Per capita waste in kilograms per person per day, per capita GDP, and once again the total population. This is in the waste versus GDP data frame. We'll look at the per capita waste column. I'm once again counting how many missing values there are. The exact same numbers as the second data frame. 22,018 missing values out of 22,204 observations. So that is curious. I have a hunch where most people did their observations, and it's not a bad idea. I just want to double check some things here. So we got mismanaged waste, per capita mismanaged waste. And plastic waste in general. So now this is kind of For someone who hasn't been looking at this data for long, I've been looking at this for, what, maybe 10, 20 minutes now. And it looks like I could make a comparison between mismanaged waste and the general plastic waste, maybe more intentional. What I find odd about these numbers is that these are already per capita numbers. So do we need the population? That's what I'm wondering. In the future, if I decide to make these videos in a more professional way, I imagine this is where I'm going to make an editor's cuts. So the issue, part of the issue is there's a lot of data here, but only about population, and of course the years and as such, and it's probably not going to be all that useful for us to keep all this data. Instead, we're going to not find data, par the data down. We're going to focus on the data that's not missing. By the way, for a good report, there should be some sort of introduction. So let's go back to the Tidy Tuesday page. Admittedly, I'm just going to copy and paste what they said about the situation, put in quotation marks so you know it's not me typing that. As a side note, part of my coding style is later on what I would be able to do is to make 2 copies of this report. One with the code for replication amongst fellow data analysts, and 2 without the code for people who are not as familiar with our data science techniques or statistical techniques and who want to go straight towards the results. Fortunately, this Markdown coding environment allows us to make that distinction. Now, again, what I want to do is clean this up a bit. Convention is to call this a tidy version of the data frame. What we're going to do is take this cost versus waste, and the convention is you either select some columns or filter some rows. And of course there are other tools that could utilize at the moment. So what I want to do is look at the columns where this mismanaged plastic waste is not missing, where we have no missing values here. As you figured, this command is.na does count the missing values, and thus if I want to do the opposite, the syntax in R is to put an exclamation point in front, and let's see if this all works out now. And this will focus on the 187, if you see here in the top right, the 187 observations where that particular column was not missing, and now we can see our data start to come alive. So you can see a worldwide effort in 2010 to start to keep track of plastic waste. And I suspect that these countries, given the name of the data frame, these countries all have some coastal communities. with these columns of numbers, the year is constant. We're not going to use that too much, except to make a note of that on our report. You can see that the obvious calculation will be to take the mismanaged plastic waste and divide it by coastal population. We suspect that countries with a larger population would make more waste. On the other hand, let's not punish certain countries or regions for having fewer people. Good thing I scrolled through the data here. Notice that there is a world column that has would presumably total all these numbers, but for the sake of my analysis, I'm going to want to get rid of that as well. So going through here, we could do that again. Filter, what was the name of that? Where our code be careful, it's capitalization there, is not equal to the entire world. Running that line again, there should be 186 observations now. Fantastic. Is that true in the other? Actually, let me just do it this way. We'll do that same bit of code. I'm going to take the second data frame, create a so-called tidy version of that, check where the fourth column is not empty. This was per capita mismanaged plastic waste. And I'm gonna actually only run this chunk of code so far. We got 186 observations. We have a similar look here. Data from 2010, a variety of countries and regions. This time around, the world is not a total, but I still got to worry about some missing values in the fifth column. Maybe not. Let's see now. Keep in mind that the code we just did eliminated missing values in the fourth column, so that doesn't matter as much. Okay. And thus, with this data frame, we did not need to filter out one more row. Let's do that one more time for the third data frame. Taking the waste versus GDP data frame, we're going to make a tidy version of it. Notice, when I say make a tidy version of it, I'm being kind of facetious here. I'm literally just putting the word tidy on this for now. And the column name that we looked at before was per capita plastic waste. Running this code, we get a third data frame with 186 observations. I'm going to guess that each one of these data frames now have listings for the same countries, but it is possible to get around that if for some reason, say the first data frame talked about countries that started with letter A, and the second data frame talked about countries whose names had 5 letters in them. It is possible to merge them together. Fortunately, that will probably not be an issue here. Well, I'm at 25 minutes now. Well, it looks like my original plan for 30 minutes is defenestrated, Instead, maybe I'll go for an hour-long video. And again, this is all a rough draft for me. Let me see if this file even works so far. Okay. Nope. Didn't really have a good programming practice. I should make some sort of comment or description of what I did here. Most of the data on waste comes from the year 2010. Missing for older observations. Here we will part down the data to focus on observations where the waste measurements were recorded. I probably could have come up with a more succinct way of saying that, but that'll do for now. The point is, at least for myself, if I come back to this later on, I'll know what I was trying to do. And when I say most of the data, let's say over 95%. Is that right? It's actually over 99%. I put that in the wrong place. There we go. We dealt with all that because for the columns we might be interested in, the missing data consisted of over 99% of the rows. Now, as that said, what do we want to focus on now? Fortunately, with the naming conventions, it's easy for me to figure out which data frames I have up here. I could focus on the tidy ones now. We have our cost versus waste. We have our mismanagement versus GDP, and our waste versus GDP. Maybe in a future week I'll take us on a three-dimensional tour of data, but for now, just to kind of get used to the workflow, it's better to focus on just two columns, make a quick graph in the conventional sense, an x-axis or y-axis. I think I should merge the data. I don't want to assume that all these country names are the same. They probably are, but I just don't want to assume that. When we merge the data, the columns we're going to be interested in, this mismanaged plastic waste, maybe the coastal population, mismanaged plastic waste, the per capita mismanaged plastic waste, and the per capita plastic waste. Because those column names are different, the merge will be pretty easy in that respect. Each one of these data frames still has the total population column on there. Notice quickly that the numbers are the same. Now, when I do the merge, fortunately in R, this will not create a conflict, as the program should simply keep two copies of this population data. So we're going to merge the data. It's a slightly advanced skill, something that if you're working with real-world data sets, you have to learn pretty quickly. In order to avoid assuming which countries are represented in the clean data sets, we could merge the data. Now I'm going to focus on the per capita mismanaged plastic waste and the per capita waste in general. So I want to merge two data frames. I admit that I rarely have everything memorized, so I'm going to briefly look up the join function that I need. The one I'm going to use is the inner join. It's amongst all these choices here at this particular moment, it's actually not going to matter. But here, what I'm saying is that when I combine the data set about mismanaged waste and the data set about waste in general, I only want to talk about the countries where both numbers were recorded, where both observations or sets of data are available. And that's what inner join does. If for some reason we had missing data, if for some reason we could not find a per capita mismanagement of a particular country, then the inner join will avoid this. Going back to R, save every few minutes. Going to make some joint data here. Going to inner join from the dplyr package. The first data set, the second data set, and in particular, what is in common with these data sets. Well, the entity, the country code, and the year are all in common. I have a hunch that for a nice looking graph at the end, what we're going to want to focus on is the entity. And you literally tell the R program at this point, oh, it's like to bring this up a bit so that you can see which column we're going to focus on. The joint data is still 106 observations, but now on my left you can see the country name, country code, year. The .x simply means that it came from the first one of the data sets that I happened to put in that inner join function. And the .y likewise is the numbers that came from the second data frame that I put in the inner join function. Notice that some of these columns are the same that I briefly mentioned before. Fortunately, when we talk about this data with other people, the units for the plastic waste are both in kilograms per person per day for both of these columns that I'm going to be looking at. So we don't have to worry about rescaling these numbers. But nevertheless, because I don't work in environmental fields all that often, it's probably a good idea to see what that data looks like in terms of, I want to get a sense of what a small number is and what a big number is. For example, the per capita mismanaged plastic waste. We're going to have an average of about 4% of a kilogram per person per day. And in some countries, we're looking at 30% of a kilogram per person per day. That's the mismanaged plastic waste. Similarly, we could look at the plastic waste in general. And sorry, I should have kept both the numbers on the screen, but sets of numbers on the screen. But we do have higher numbers here. Now, there are a couple different directions we could go with just these two columns. I'm going to go with the simple one, putting one on the x-axis, putting one on the y-axis, and just see if there's some sort of relationship between them. That is, my hand-wavy hypothesis is that countries that create more plastic waste also create more mismanaged plastic waste. And these are already normalized numbers. These are already per person, or however you want to say it. Even if it was said per 1,000 people, these are already normalized numbers. Another way to do this is to look at proportions, see which country create plastic waste, of course, but then see which countries by percentage mismanage more of that. And maybe time permitting, we'll do both. So let's plot the data now. I'm going to take our joint data, pipe it into a ggplot. I'm going to put the I'm thinking putting the plastic waste in general on the x-axis, and then the mismanaged plastic waste on the y-axis. If I'm looking for a correlation, that doesn't really matter. It's just that I'm implying that the plastic waste comes first, in some sense. Now, I'm going to walk us through this one step at a time. First, to see what the... Whoops. what the data looks like. You know, it would help if there were any dots there, wouldn't there? Okay. So, we have a bit of an outlier here. Now, of course, another consideration in general is that I have 186 observations still, and could I condense that onto a graph that makes sense, that kind of tells a story? How would I want to do that? And of course, we also want to discover who's making this dot here all the way to the right. One thing I was considering is maybe just slicing the data, whoever was above the mean in plastic waste, but I think what would be better is actually looking at the top 10 countries themselves. But while we're here, let's clean this up a bit. Let's add a linear regression. And depending on the audience, the gray background is not really necessary, so that we could see, at least, especially with this outlier, we of course have that positive correlation that the more plastic waste a country creates, the more they tend to mismanage it. And to be in a good habit, let me show you how to add titles and fix the labels. Could have a title, could have a subtitle. So remember that all the data is coming from the year 2010. This might be a good place to put that. Could have a caption. What I like to usually put in the caption is the source of our data. In this case, this is our world in data. Give them credit. Along the x-axis, this label is pretty good, but it's actually redundant to say all of that. Maybe sticking with just the words. If I needed to include the units, kilograms per person per day, I could include that elsewhere in the report. And this was mismanage plastic waste on the y-axis. Oops, I forgot a plus sign. This is what happens when you forget a plus sign. I'm going to put the plus sign back in. And now we got a slightly cleaner graph. Have our title, plastic waste around the world, our subtitle, year 2010, our caption down here in the bottom right, our world and data, and some cleaner X and Y axis labels. Now, what I want to do next is add text to the scatter plot. Yeah, I think it's geom text or geom label. It's easier for me usually just to go to the example here. So it's geom text, but we need a label here. Okay. My personal style is to try to keep all these lines of code, all these so-called layers, in alphabetical order, so that if I'm debugging the code, I could figure out where I needed to be later. So we have our geom text. Notice that there were a couple different choices here. This came from how I merged the data earlier. I didn't make a distinction if the country codes, the 3-letter abbreviations, were coming from the first data frame or the second data frame. That's why they're given temporary suffixes, the .x, .y. And let's see what this looks like. Okay. So the country code is TTO. Might have to look that up later for that outlier. Now notice that the 3-letter abbreviations are on top of the dots. There's a way to get around that. I'm pretty sure this tutorial page says that really quickly. There was actually a better way to do this. I'll think about it next time, but I want to, in the time I have here, finish this couple of trains of thought here. Maybe move this up 0.1 units. That's still too much. Sometimes these units are actually the same units that we see on the Y value. I'm trying to move these 3-letter abbreviations up or down, but still be near the dots that they represent. And maybe a little closer than that. That's pretty good. Okay. So as you can see, the labels are there. It's going to be pretty convenient in figuring out some countries to focus on our analysis, but But since there are 186 countries and regions represented in the data, this is still not all that aesthetically pleasing, and maybe not telling us a lot of information. So I think finally what I want to do is focus on kind of a top 10 in some sense. Which countries are producing the most waste per person, because that's the data we're looking at right now, and then go from there. So once again, I'm just going to Google this. This is a dplyr scale top N. And I think what I could do is, let's call this a more focused example. I'm going to be able to take all the previous code that I made, and the one line of code I need to do to adjust this is that we're going to take the top, let's say 10 countries based on their per capita plastic waste. Now, at this point, the regression line is kind of disingenuous, so I'm going to take that out. Let's see what this does here. So now you can see at least a bit of a better view of the situation. Not as many dots and labels to consider. and we could focus on the countries here. What is TTO? What is that? Trinidad and Tobago. According to the data, the residents there are producing the most, what's this over here? The most plastic waste, but that also might be a consideration of where they are little in the world, how their disposal systems might be inhibited by the nature of being islands. And thus, that really finishes our Tidy Tuesday adventure for this week. Hope you enjoyed that. I'm gonna try to make more videos as the summer progresses, and we'll see how this goes. Until next time, keep coding.